Okay, this video is a demonstration of a little bit more challenging division problem. We're going to be dividing two imaginary numbers, but they're not going to be just simply expressed, shall we say. A little bit more difficult. I've got negative exponents, I'm multiplying in my denominator, that sort of thing. Okay, let's get started on this one. I usually encourage my students just to look at the problem and see what you notice, because sometimes the littlest detail actually helps quite a bit. What I'm noticing in this problem, which looks a little unusual to me, is that I've got a negative exponent, and I've also got something that's multiplied. Now remember, when I think of PEMDAS, the order of operations, you have to do the exponents before you can multiply anything. So I'm going to take care of that negative exponent. Now what does a negative exponent say to do? Because again, it's like a little instruction there, isn't it? The negative exponent is saying, move me to the opposite side of the fraction. Aha. So I'm going to move 1 plus 4i up into the numerator. Now notice I didn't bring along the 4i because it didn't have the exponent on that. It just had it on the parentheses. So I brought that up there, and then you change the sign to a positive 1, which we really don't need. So in my second step, what I've done is just moved up the 1 plus 4i into the numerator. That considerably simplifies things. I've got a FOIL up here and then a 4i down here. Let's do the FOIL first. 1 times 1 is 1. 1 plus 4i, 1 times rather 4 plus 4i is 4i. Negative 4i times 1 is a minus 4i. You might recognize that as a difference of squares, so I can cross those guys out. And then that times that is a minus 16i squared, all over 4i. I might be tempted, let me just rewrite this really cleanly if I could. I get 1 minus 16i squared all over 4i. I might be tempted to try to simplify this, but remember you can't do that because there's a plus or a minus sign up here, so it kind of sticks these two guys together. I can't reduce just this part without doing anything over here. So what I'm going to do instead is I'm going to take care of the I squared. And I remember that I squared is equal to negative 1. Remember, I squared is equal to negative 1 is one of those identities for imaginary numbers. And again, all over 4i. That's going to give me, step 6, 1 plus 16, or 17 over 4i. Okay, we've done really well so far. Remember, though, that you cannot leave an imaginary number in a denominator. You want to try to express it as a plus bi form. So how do I get rid of that? How do I get that negative, or excuse me, how do I get rid of that imaginary number and put it in the numerator? Well, like you do with radicals, you're going to multiply by the number itself. So 4 times I squared is going to give me, or excuse me, 4i times I is 4i squared, and up top I get 17i. Remember what we said, I squared is just equal to negative 1, so now what I've got is 17i over 4 times negative 1, or 17 over negative 4i. Now that's not quite that's actually a perfectly acceptable answer, but if I want to really be exact here, right, I'm going to put 0 plus, oh actually in this case it's 0 minus 17 over 4i as my final answer. Okay, I hope that helps. Remember, multiply by whatever is going to get rid of that, and normally it would be just the I. I don't have to put the 4 there, or I could have. But once I get I squared, I can change it to a real number, and voila, I have rationalized my denominator. All right, good luck. I hope that helped.